In this video, we're going to write some code so that an LED turns on if something comes close to our distance motor or if our distance motor comes close to something else. So what I've done before I start writing my code is I've plugged in an LED into port 1. That means the orange lead in my case, or the whatever color your LED, that lead goes into the plus in LED port 1, and the black lead goes into the negative. Similarly, for the distance sensor, I'm using port 1 of the sensor's ports. The yellow lead goes into S, the red lead goes into the plus sign, and the black lead goes into the minus side. I've plugged in my board and I'm ready to code. So the first thing I need to do, this is just I went File and I open a brand new Arduino file. And the first thing I need to do is I need to import the Hummingbird library. That's all the possible functions I could use with the Hummingbird. So I'm going to say include space, there's a number sign, include space, little caret, shares the space with a comma, Hummingbird with a capital H, dot lowercase h, close carets. So this means I have access to all the Hummingbird functions. Next, I want to give my own personal Hummingbird a name. So capital H Hummingbird is saying I'm going to be giving a name to a Hummingbird object. Then I'll call mine Tweety. Don't forget the semicolon. Here in setup, which only happens one time right when you first run your code, the only thing you need is to initialize your Hummingbird board. So it's board name, so Tweety is the name I gave it, dot init, which is short for initialize. This just gets it ready to go. He's all set. He's got everything, access to all the possible functions we've imported up here. Down in loop, this is where I'm writing the code that will happen when I run the program. So if I just wanted to turn on the LED and have it be on forever, I would write board name, so Tweety dot set LED. Make sure capitalization is correct. Open a parentheses. 1 is the port it's plugged into, and 255 is max brightness. So this would just get me, if I ran this, if I uploaded this code, it would just turn the light on and it would stay on forever. That's not, of course, what we're doing. To only have that happen when something gets close to the distance sensor, I need to use what's known as a conditional statement or an if statement. And that's just going to check a condition and then have a function happen, or more than one function happen, if that condition becomes true. So the way the distance sensors work is they take basically they're always sending an integer value, a number value to the board. The closer something is to it, the higher that number value is, from 0 up to 123, or 1023, excuse me. So the easiest way to do this is to make a new what's known as a variable that will store that number, the number representing how close something is. So if I say int, that means I'm going to make a new variable and it's going to be an integer variable. So d, I'm saying d because that's the distance away that the object is, or the distance the sensor is from an object, equals Tweety dot read sensor value, and again, those capitalizations are important. I'm going to open a parentheses, put a 1 in there because it's plugged into port 1, and close. That means every time this loop method happens over and over and over again, it's basically continually checking, reading the sensor value from port 1 and assigning it to D. So now D stands for that sensor value. So if something's nearby, the number is going to be high. If something's far away, the number will be low. Next, I'm going to set up that if statement, like I said. So I'm going to say if D, which now, of course, is the distance away, the distance sensor is from an object, is greater than 100, because it means something's close to it. It's getting a high value. I'm going to close that parentheses. Now I'm going to open a curly bracket. Once I hit enter, it's going to add another curly bracket down here. That's leaving me the space to put the functions that will only happen if this becomes true. So I'm going to write Tweety dot set LED 1, 255. So that's if something gets close, it's going to turn the LED on. Now I want to make sure it turns off if something becomes far away. So I'm going to use what's known as an else, which just means that for any other circumstance, I'm going to do a new curly bracket. So this means anytime that this is not true, that D is not greater than 100, that something isn't close to the board, I want it to turn that light off. So that's Tweety dot set LED 1. Again, that's the port number, and 0, that means turn off. Now this is good because this all the code in here keeps looping through over and over and over and over and over super fast. I find that it's actually really helpful to say we want to slow this down so it's not happening so super fast. That means it's only going to check. I'm going to check basically 6 times a second by delaying. No, not 6 times a second, 100 times a second. Yeah, 100 times a second by putting a little delay of 10 milliseconds in here. Sorry, it's going to be programming languages messed up right there. So I'm going to say delay 10, and this means that every 10 milliseconds, it's going to pause 10 milliseconds after this before getting that new value of D. So it's not going through over and over and over and super fast. It's slowing it down just a little bit so it has more time to sort of process and change the value of the LED. And I find this makes for smoother transitions if we don't include this delay down here. So that goes after else, but before the close of the loop. So now you're ready to upload this, but we want to go to Tools, make sure that your board is the Hummingbird Duo and your port is the USB port, not that Bluetooth port. If you don't have this as an option, we're going to have to do some troubleshooting. Make sure that your Hummingbird is in the correct mode. There's a video for that as well. So these is both true. You can click the check mark to compile it. Make sure there aren't any errors. When it's done compiling, you can click the arrow to upload it to your board. And if it's working, as you move your hand closer or farther away from your distance sensor, the light should turn on and off.